Morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to solve word problems that involve direct translation, geometry, and uniform motion. So it's going to be a good lesson, very powerful, very important. So try to pay attention and do your best. All right, so let's get right to it. Direct translation word problems. Think about what the words here mean. Direct translation. There's not much to think about here. You're going to literally translate the words in the word problem into math. So let's do that. It says the sum of two numbers is 45. Twice the first number less the second is 27. I don't want to jam myself up, so me personally, I'm always going to label. I'm going to call x the first number and y the second number. It is up to you what you call your variables, but that's what I'm going to do. So now I know that the sum of two numbers, the first and the second number, is 45. That's my first equation. And then I also know that twice the first number, so 2x, less minus the second, which is y, is equals 27. And there you have it. You have my system. I'm going to solve this by elimination because it is already in standard form. So I'm going to add these two together. The y's cancel. I've got 3x is equal to 72. Divide 3 to both sides. And x is 24. And now we know how to solve for y. We go ahead and just plug it into either of the original equations. So me personally, I'm going to plug it into this guy right here. So I've got now 24 plus y equals 45. When I subtract my 24, y equals 21. And those are my two numbers. And there you go. Next, the sum of two numbers is 104. The second number is 25, less than twice the first number. Find the numbers. Don't stress. X I'm going to call my first number. Y I'm going to call my second number. I'm going to read it again. The sum of two numbers is 104. So the sum of my first number plus the sum of my second number is 104. And it says the second number is 25 less than twice the first number. So the second number, which is y, is equals 25 less than. Remember that in less than you switch. So it's 25 less than twice the first number. So that's 2x minus 25. And there you have it. You have your system. Now in this particular case, I'm going to use substitution because they gave you the value of y. I'm going to plug that value into the y of the first equation. So I've got x plus 2x minus 25 equals 104. And then I'm going to have here 3x. I'm going to add my 25 to both sides. Then I'm going to divide that by 3. And 129 divided by 3 is 43. So that's my x. And then to find my y, I'm simply going to plug it in to either of the original equations. I'm going to go ahead and plug it into the second one because it's already set up for the y value. So I've got y equals 2 times 43 is 86 minus 25. So y is going to equal 61. And there you have it. All right, next. Let's continue. Geometry word problems. Don't stress. Pay attention. This is going to be fine. The Gomez family just bought a wooded lot that is on a lake. They want to enclose the lot with a fence but do not want to put up a fence along the lake. That makes sense. John Gomez determined that he will need 240 feet of fence. He also knows that the width of the lot is 30 feet less than the length. What are the dimensions of the lot? Well, He's got this lot here. He does not want a fence over here in blue here. He does not want a fence on the lake. He does want a fence, though, along the other three sides. So the first thing that was given to you was that he determined that he's going to need 240 feet of fencing. Well, let's think about that. 240 feet are needed for one width, two widths, plus the length. We know that. That's a fact. That's how much fencing we're going to need for the three sides of the fence. He also knows that the width of the lots, W, the width, is 30 feet less than the length. So the width is the length minus 30 feet. And one thing I should have done, and I apologize, I'm going to go ahead and say that L is length. I know it's pretty self-explanatory in this situation, but I wanted to show you. W is width. So now I'm going to go ahead and solve by using substitution. So I'm going to go ahead and substitute my value of width into the width of the first equation, giving me 240 equals 2 times parentheses L minus 30 plus L. I'm going to go ahead and distribute that 2, giving me 2L minus 60 plus L. Add the 60, combine like terms. I've got 300 equals 3L divided by 30. So the length is 100 feet. So if the length is 100 feet, how do we find width? We plug it into the width equation that we formulated. We know that the width equals the length of 100 minus 30. So the width is 70 feet. And there you have it. Now you know the dimensions of the lot, which are usually in length times width. So the dimensions, this is a 100-foot by 70-foot lot. All right, awesome. Next, the perimeter of a rectangular field has a perimeter of 400 feet. The length of the field is 3 times the width. What are the dimensions of the field? Whenever you're dealing with rectangular perimeter, remember there is a formula. Remember that a rectangle has opposite sides that are equal. So the perimeter, or the distance around the rectangle, is going to equal 2 times the width plus 2 times the length. I'm going to go ahead and call W my width, L my length. And now the perimeter, we know, is 400 yards. So let's get to work. How do we solve this? It says here that the perimeter of the rectangular field is 400 feet. So 400 equals 2 times width plus 2 times length. And it says the length of the field, L, is 3 times the width. I'm going to go ahead and use substitution. And I'm going to plug in the value of L into the L of the first equation. And I've got 400 equals 2W plus 2 times 3W is 6W. So 400 equals 8W divided by 8. And W equals 50. All right. And now, what do we do with that information? Well, we can go ahead and plug it in to my length equation that we created and find the length. So the length here is going to equal 3 times the width of 50. So my length is 150 yards. So what are the dimensions of this field? Again, dimensions are usually written in length and then width. So the dimensions would be 150 yards by 50 yards. There you have it, geometry problems. All right, let's go. Okay, some more in geometry. Talk about complementary angles. Complementary angles are angles that add up to equal 90 degrees. Okay? So that means the first angle that they give you plus the second angle that they give you has to equal 90 degrees in order for the angles to be complementary. So with that knowledge, it says find the measure of two complementary angles such that the measure of the larger angle is 6 degrees greater than the measure of the smaller angle. Well, they give you a little clue here. They give you a smaller angle and a larger angle. So I'm going to go ahead and say that X is my small angle, Y is my larger angle. And I know that these angles are complementary. That means that the smaller angle plus the larger angle must equal 90. And then it tells you that the larger angle, Y, is 6 degrees greater than the measure of the smaller angle. So it's 6 greater than X. This is a situation for substitution. So I'm going to go ahead and substitute the value of Y here into the Y of the other equation, giving me X plus 6 plus X equals 90. I'm going to subtract the 6, combine like terms, giving me 2X equals 84 divided by 2, X equals 42 degrees. And that's my small angle. And then to get my large angle, we'll simply plug it in. 42 plus Y equals 90. Subtract 42 to both sides. And Y will equal 48 degrees. And there you have it. Complementary angles. Very similar to complementary angles, or at least the concept, is something called supplementary angles. But supplementary angles have a sum of 180 degrees. So in other words, the first angle plus the second angle must equal 180 degrees if they are supplementary. So it says find two supplementary angles such that the measure of the larger angle is 16 degrees less than 3 times the measure of the smaller angle. Once again, I'm going to go ahead and call X this time I'll call it my larger angle, and I will call Y my small angle. We know that they're supplementary, so my large angle X plus my small angle Y must equal 180. And it says the larger angle, which we defined as X, is 16 less than 3 times the smaller angle. And in this case, again, we are pretty much set up for substitution. So I'm going to go ahead and take the value of X and plug it into the first equation, giving me 3Y minus 16 plus Y equals 180. 4Y equals 196. I added the 16 and combined the like terms. And then I'm going to go ahead and divide that by 4, giving me 49 degrees. So my small angle is 49 degrees. And then to find my larger angle, I simply plug it in. X plus 49 equals 180. Subtract the 49 to both sides, and X equals 131 degrees. And there it is. All right. Last two. We're almost done. This is by far the most important. This is very, very common and very useful. And it's not as hard as you think it is. So bear with me, take a deep breath. We got this. It's uniform motion word problems. In uniform motion word problems, we're going to be talking about different automobiles going different speeds, different times, and different distances. Please remember that when we're dealing with uniform motion, distance equals rate times time. Distance equals rate times time. And also remember something else. Let's go back in time and pretend you were on your bike, you're riding downhill, and the wind is going against your face. Okay, that wind is slowing you down. But at the same time, if you're going downhill and the wind is going at your back, it is pushing you. It is speeding you up. Think about that while we're reading this question, please. The airspeed of a plane is its speed through the air. This speed is different from the plane's ground speed as its speed relative to the ground. Both the airspeed and ground speed of an airplane is affected by the wind. Suppose that a Piper aircraft flying west against the wind, a distance of 500 miles, takes 5 hours. The return trip flying east with the wind takes 4 hours. Find both the airspeed of the plane and the wind speed. All right, don't stress. First things first, Morrow's got a great table for this. Remember that distance equals rate times time, so go ahead and make a little table here. Trust me on this. And remember that rate times time equals distance. And we're dealing with two different things, okay? The plane, first of all, is going with the wind at one segment and then against the wind with the other segment, okay? So it's going west and it's going east depending on when we're traveling. When it's going west, you're going against the wind a distance of 500 miles and it takes 5 hours. Now, let's go ahead and call x the plane speed, okay, the airspeed of the plane. And let's call y the wind speed. When I'm headed west, I'm going against the wind. So it's my plane speed x minus my wind speed y. Think about you on that bike. You're pedaling, but the wind is going against you. It's hitting your face. You're losing speed. Now, on the return trip east, it takes 4 hours to travel the same 500 miles. And this time you're going with the wind. So it's your plane speed plus the wind speed. Think again about you on the bike. The wind is pushing you, pushing your back. It's adding speed to you. And there you have it. With this setup, now you can create a very simple and useful system to solve. So, remember that when you're multiplying, you're going to distribute when you have a sum. So you have rate times time, so that's 5x minus 5y equals a total distance of 500. And then you have 4x plus 4y equals 500. And you can go ahead and use elimination to solve. However, I'm going to show you a little bit of an easier way and a quicker way to do this. Instead of distributing it, just set up the equations first. What am I talking about? 5 times x minus y equals a distance of 500, and 4 times x plus y equals the distance of 500. Before distributing the 5 and the 4, let's go back in time. And remember that you can divide 5 to both sides here. And you could divide 4 to both sides here. And then you're going to be left with x minus y equals 100. And x plus y equals 125. If you go ahead and solve now using elimination, the y's cancel. I've got 2x equals 225. Divide 2 to both sides, and x will equal 112.5, and this is in miles per hour. And now, how do I solve for y? Don't make a mountain out of a molehill. Plug it in to the equation that you already simplified. So you've got 112.5 plus y equals 125. Subtract the 112.5 to both sides, and y equals 12.5 miles per hour, and that is your wind speed. So my plane speed was 112.5 miles per hour, and my wind speed was 12.5 miles per hour. Not bad, right? A little bit of work, but not bad. All right, let's try one more. A plane flew 1,200 miles from MIA against the wind for 4 hours. The plane returned to MIA over the same route while flying with the wind in 3 hours. Find the airspeed of the plane and wind speed. All right, let's make our table. Remember that rate times time equals distance. And we have 2 routes. We're going from MIA on the first leg, and then we're going to MIA on the second leg. And on the from trip, we traveled 1,200 miles against the wind for 4 hours. So let's go ahead and call x my plane speed, and let's call y my wind speed. So if I'm going against the wind, it's my speed minus the wind speed. And then on the return trip to Miami, I flew the same distance for 3 hours, but going with the wind, so that was adding to my speed. All right, my system of equation, 4 times x minus y equals 1,200, and 3 times x plus y equals 1,200. Let's go ahead and simplify this here by dividing 4 to both sides in the first equation, 3 to both sides in the second equation, giving me x minus y equals 300, and x plus y equals 400. Now I can solve this system by elimination. 2x equals 700 divided by 2. X equals 350 miles per hour. And then, me personally, I'm going to use this second equation here, plug in my x to find y. 350 plus y equals 400. And y equals 50 miles per hour. Excellent. So my plane speed is 350 miles per hour, and my wind speed 50 miles per hour. Always look at the answers and make sure that it makes sense. For example, if we had made an error and we had said that the wind speed was 350 miles per hour and the plane speed was 50 miles per hour, we'd have a little bit of a problem because the wind would be overtaking the plane. So always make sure for logic when you're working with word problems. And thank you so much. I hope you learned a lot. Come back anytime, and you have a great day now. Bye-bye.